Okay, our last speaker of the morning is Dr. Brady Allred from University of Montana, who's going to tell us about the new Rangeland Analysis Platform.
Thank you, Charlie, and thanks for putting together such a wonderful set of talks this morning and this afternoon. I get to work with a fantastic group of people, many of which spoke this morning, many of which are going to speak this afternoon. And one of our primary purposes is to provide science support for the NRCS. And as Jason Tack said, that science support comes in the form of developing conservation strategies, developing tools, and most importantly, using those tools to help evaluate the outcomes of these conservation actions. I think it's important to take a step back here for a moment. At the highest level, the goal of the NRCS is to make sure that this never happens again. The Dust Bowl was one of the worst ecological disasters on this planet. We're coming on almost 100 years now that it's happened, and I've taught classes where people don't know what the Dust Bowl is. People tend to forget things as time goes on. The Soil Conservation Service was born out of the Dust Bowl. It was literally an act of Congress said, we are going to put resources, we're going to put an agency together to make sure that this doesn't happen again. Now, at the day-to-day level, this is what the NRCS does. The NRCS does not own or manage any land. One of their mottos is helping people help the land. They work with private landowners to do conservation practices. Those private landowners, that private land is an essential component because it makes up most of the land in this country. If you forget about those private landowners, if you forget about that private land, conservation will not be successful. These conservation practices come in the form of technical and financial assistance. And in nearly every county of the United States of America, you can walk into an NRCS office and get information and get help about something to do with your land, whether that's crop agriculture, whether that's rangelands, or even if you want help growing a garden in your backyard, they will provide that assistance. And I think we take this for granted. I was at a meeting 2 weeks ago with NGOs and conservation organizations from around the world, and nothing like this exists elsewhere in the world. So it's an amazing enterprise. Now, I'm a rangeland ecologist, and rangelands take up a bunch of the lower 48 states, more than a third. And the biggest question that we've always had is, because rangelands are so large, take up so much space, how do you monitor these rangelands effectively and efficiently? And again, most importantly, how do you assess the conservation outcomes? How do we know what we're doing is doing a good job for the rangelands or for the wildlife or for any other thing that we're interested in? Now, sage grouse biologists are not the only ones who like to spend their time looking down on the ground. The rangeland discipline has a very long history. In fact, we excel. We are probably the best in the world of looking down on the ground at our boots. We know how to identify plants. We know how to count the glooms on grass florets. You probably don't even know what a gloom is, but we do, and we know how to count them, and that will help us identify plants. We have spent time and resources to do this and to do it well, and we do it very well. The problem is this isn't monitoring. When you Google rangeland monitoring, these are the photos that come up. These are rangeland inventories, and that is what we do really well. What's the difference between inventory and monitoring? Well, here's a landscape that has about 15 inventory plots scattered across the landscape. These are real monitoring plots and sampled across 4 years, and those plots make up less than 1% of the landscape. So our inventories give us valuable information. I'm not knocking them. We really need them. It helps us understand what's going on out there at the landscape, but it isn't monitoring. And so the big question that we tackled as a group is, how do you move from these inventories that we do so well at to actually monitoring across space and through time? How do you do that? And how do you do it effectively? So the answer has always been remote sensing, right? Remote sensing is going to solve all our problems. I'm not the first one to say that. This is a paper that was written in the Journal of Range Management in 1976, entitled A Remote Rangeland Analysis System. So they were talking about this back then. This was before I was born. I had not come into the world yet. People were talking about this. And we do that. The map I showed before is a map of rangelands. It's also a map of other land cover types across the United States. We use remote sensing imagery, satellite imagery, to map rangelands. But is this the best we can do? Is this what we want? What this gives us is categorical classes of rangelands, pasture lands, forest lands, croplands, other types of lands, right? But they're just categories. Is it helpful for rangelands managers to know that their pixel or their ranch is rangeland? It might be if you do this enough through time and you're interested in seeing how things change, but so often the case is we don't do this through time. It's only updated every 5, 6, 7 years. They're not updated as often as they need to be. So what we did is we gathered a bunch of rangeland inventories that have been collected over the last 15 years through various programs, the NRI program associated with NRCS and the AIM program associated with BLM. We have about 40,000 on-the-ground inventories. That's as many arthropods as Hayes collected in his one study. So we have 40,000 on-the-ground plots that have very detailed information down to the species of what is in that more or less half acre plot on that landscape. That looks like a lot of plots. That's all the 40,000 scattered across there on the map. But again, this is a very big landscape we're dealing with. So it doesn't cover every bit of ground. And so what we did is we combined that with satellite imagery, lots and lots and lots, 2 petabytes of satellite imagery and a whole bunch of other data sets. And we used some machine learning algorithms to build a model that will provide us a little bit more useful information than what we had before. And what we produced are maps that are updated annually of rangeland functional groups. Rangeland functional groups are things like annual forbs and grasses, perennial forbs and grasses, trees, shrubs, bare ground, right? These aren't species levels indicators. These are broader level indicators of how our rangelands are performing. So what we did is we produced that at a medium resolution of approximately 30 meters. 30 meters is the size of a baseball diamond, more or less, across the entire western United States, western rangelands, from the Great Plains to the Pacific coast. One of the new things that we did is we didn't produce categorical measurements. We produced continuous measurements, measurements that go from 0 to 100% for each one of these categories. So now we no longer just know that it's rangeland. We know how much of these functional groups are there, how much grass is there, how much bare ground is there, how much trees, shrubs, so on and so forth are there, an actual percentage. And lastly, we provided temporal coverage from historic to present. Starting in 1984, when the satellite imagery archive really ramped up and was really beneficial, all the way to 2018. And we're going to continue to produce these annually as we go forward into the future. So for the first time, we can actually say rangeland monitoring has been checked. We are doing it across space and through time. Now, the big question is, what can we do with these data? What are they useful for? What's the utility of these data? I'm going to show 3 examples at 3 different scales that kind of demonstrate the utility. So because we're doing rangeland monitoring for the first time, we can actually take an assessment of the state of rangelands nationally. We can say, how are our rangelands doing? And so what we're looking at here is a map of perennial forbs and grasses and looking at the trends from 1999 to 2018. Anything in green is increasing cover in perennial forbs and grasses, and anything in red is decreasing cover and perennial forbs and grasses. So this is information that we have never had before. We can see in the northern Great Plains up there in Montana, where I come from, the rangelands are doing well. Our perennial forbs and grasses are increasing. We are the management actions we are doing up there at this national level is working, it's doing good. We can see at other regions of the country, particularly the southern Great Plains, that our perennial forbs and grasses are decreasing. And Caleb Roberts this afternoon after the break is going to talk more about that and what that means. Why is this important? Because decisions are made at this national scale. We collect all this data and we produce all these data sets because someone has to make a decision to do something. Where to put money, where to put resources, what initiatives to launch, what do we need to tackle? And decisions are made at this scale, and so it's important to have information at this scale. Going down to a little finer scale, a regional scale. This is the Great Basin. Reno's on the edge of that, there on the edge of Nevada. This is a figure that was produced for an article in Bloomberg that showed the increase of annual grasses on the left starting in 1990 to 2018 on the right. And if any of you are familiar with this region of the country, you know that that specific annual grass that we're talking about is cheatgrass, which disrupts the fire cycles and causes some concern out here in the West. So we can now document that increase in annual grasses across this time period. We can say, how big of a problem is this? What have we lost due to the increase in annual grasses? But more importantly, we can say, what haven't we lost? Where are the places that are still good? Where are our core areas that we can still go back and put our resources there and work on them and conserve them and make sure that they stay good, that they stay intact? So we have tools and maps now available to help us make those decisions at these regional scales. Lastly, at more of a management scale, right? We've talked a lot about outcomes. Outcomes are important. Is the management we are doing good? Is it achieving the objective we want it to achieve? Up at the top, we have photographs taken in 2002 and 2010. This is of a BLM allotment in Montana out of the Billings field office. You can see the photographs there on the top. In the middle, we have maps of the perennial forbs and grasses at the same time periods from 2002 and 2010. And in the brown, we have bare ground. So we have this information spatially as well as through time. But the most important thing is that graph down at the bottom. Those dots, those squares on that line represent the years 2002 and 2010. And you can see we can document the increase in perennial forbs and grasses that we see in the photographs. So now we can document outcomes at that management unit scale. We can understand, is our management working? If it is, great. If it isn't, what do we need to do differently to achieve the outcome that we want to achieve? So we now have data sets that help us with all these three scales of decision making. Lastly, this information is of no use to me if it just sits in my office or on our servers there in Missoula, Montana. And so what we did is we built a web application that sits on top of Google Maps that anyone can access, landowners, managers, range conservationists, wildlife biologists. It's open to anyone. They can get this information, they can visualize it on the map, they can do their own custom analysis, they can upload polygons, points, lines, and they can see how their area of interest is changing in regards to this data sets. So we're taking that last step, that last bridge of actually getting this information into the hands of the people that need it. So I encourage you to go to the website, rangelands.app. You can pull it up on your phone or your tablet or your computer and give it a look. And make sure to check it out. Thank you very much.
Plenty of time for questions for Brady. Discussion? Comments? About tomatoes?
Yes, Lance.
So, every time I see you, I ask you the same question, so I might as well continue.
Go for it.
How close are we to being able to have the classifications themselves to use, so wildlife can use as overrids for things that people, not just like
As of June 26, it's available. So as of, a couple months ago, it's 1.5 terabytes worth of data. So just make sure you have enough space to download it. No, there are. We don't have a tool to clip it out, but I can show you a method to do that easily, and it's on the website. And I apologize, I forgot to repeat the question. The question was, are the data available to use as covariates in models and other situations? And yes, it is. If you go to the website under the data section, there will be a link to point you directly to that data. Yes, sir. So no, we particularly set this up to look at these functional groups: perennial forbs and grasses, annual forbs and grasses, trees, shrubs, and bare ground. And I apologize again, I forgot to repeat the question. The question was, within the classifications, can we distinguish between native and non-native species? We chose those functional groups because they are broad level indicators of kind of rangeland health and ecosystem, where you are in that health, on that health gradient. It is possible to look at differences between native and non-native, but it requires a lot more work. Yes, sir.
Layers have a measure of uncertainty associated with them?
Yeah, so the question is, are there measures of uncertainty associated with the layers? Yes, there are. This is a model. These are estimates. As with any model, whether it's a remote sensing model or a collection of data on the ground, there is error. And if you go to the website, it will explain that error and what it means and how to interpret it. Yes, sir. Yes, and so the question is, what's next for the Rangeland Analysis Platform? I just talked today about one data set, and we do envision this actually becoming a platform of data sets where this information can be useful to rangeland managers as well as anyone else who'd like to use them. The next data set that we do have planned is rangeland production. That will be parsed out into these functional groups as well, particularly perennial forbs and grasses, annual forbs and grasses, and shrubs. And that production data will be forage in terms of pounds per acre, and it will be available as annual production as well as a cumulative production every 16 days across the 34-year time period. And that will be available starting in early next year, early winter. Yes, sir. Yeah, so, remote sensing products ultimately can be used at any scale. But I think the onus is on the user to make sure that it corresponds to the information that they know about their local system, right? As I said, me sitting in my office in Missoula, Montana, I don't know what goes on in, say, your backyard. I don't know the treatments that have been applied, the management history, the weather patterns. And so there is error associated with any model that is produced. And so it's up, we provide these data sets, but it's up to the user to make sure that it corresponds to what they're seeing on the ground. And we do not promote it as a end-all be-all tool for everything. It's just another tool in the toolbox for land managers, range conservationists, and others to use to help them to be informed to make better decisions. Yes, Lance?
So when you did do accuracy assessments using some sort of cross-validation with your feeds?
Yes. Yeah, so I apologize, I forgot to repeat the last question again. The question was the accuracy of the data sets, and this was asked earlier. The actual numbers are there on the webpage, and I believe, say for examples, for trees is the one that's coming to mind. It has an RMSE of about 6%. And so, plus or minus 6% on that estimate of cover is what it is for trees. Those errors do scale because we're looking at such a large region, and say for perennial forbs and grasses, the area is a little bit larger, and that's because in the Great Plains, the cover is a lot larger than, say, out west here in the Great Basin. Thank you.
Thanks, Brady.